Yeah, thank you. See, you became now very clear with it. Thank you. Any question? Amada, you want this, please?
Okay.
Because I need this picture and I need this structure. Okay. We wrote the E frame. It's always like this. The new frame is the rotation matrix multiplied by the old one. This guy is the first rotation matrix times the N. This guy is the second rotation matrix multiplied by the E, and so on and so on. So let's do that. So here it is. We got this already. We got the E frame, right, is R epsilon 3 times the N frame, correct? We derived this. And now we're going to do the second rotation. Always the new. The new is the S is equal to the rotation matrix. This is R theta 2 times the old one, which is the E. Okay? Any question about that? And finally, the B is equal to R what? R what?
R1
Yes, very good. Times the
S.
previous, which is
S.
S. Very good. That is awesome. Okay, so I want to relate, remember the goal, I want to relate the body frame to the very old inertial frame. I want to relate B to N, and I think it's doable now, right? But please do it one at a time. Don't feel like you're very clever and just multiply the rotation matrices. Do it one at a time, not to mess up things. So here is B, is R3 times S. I'll give you some time to write. This is equal to, here is R3. Please just pay attention to this. Start with the very last relation, and then I'm going to replace S. I want to start with the very last relation, B related to S, then I want to remove S or replace S in terms of E, and then replace E in terms of N, and I'm done. Okay? B in terms of S. Please keep the rotation matrix as is, and just replace your S, please. So S from the red equation is simply R theta E, which is what? Please keep them as is. The colors help. Then E is removed in terms of the blue equation, right? R psi 3 times the B. And now, oh, thank you, times the inertial frame. And thank you. This last equation, right? This is your equation. So, yes, indeed, we can write our total rotation matrix. Here is the rotation matrix relating the new body, or the new in our language, the body frame to the inertial frame, right? And this rotation matrix, very complicated one, is the result of multiplication of 3 simple matrices. Each one is a function of one angle only, so the total is function of 3 angles. Indeed, we were able to write down the rotation matrix in terms of 3 angles only. Okay? And this applies to anything. Now, if I have a vector v, whatever, velocity or whatever, I have any vector in the inertial frame, I want to write it in the body frame, or vice versa. How you do it? It's always like this. The new, the body, is always equal to the rotation matrix multiplied by the old. It's always like this. The new this is mu, always equal rotation matrix multiplying O. It applies to frames and applies to vectors directly, components. Here I mean the components, V1, V2, V3, V1, V2, V3, the inertial vector. Any question about that? Yes,
What
Ashraf?
if the rotations are not successive? Let's say the question says first we rotate about, let's say, z-axis theta, then again we rotate about, let's say, our old y this time.
That's fine. That's
Not
fine.
the new one every time. So the rotations are not successive.
Yeah, it will just make your life here a bit harder. You see this last equation, I was able to get it easily because the rotations are successive.
Right.
That's fine if you did about the own thing. We'll just make this non-trivial, will not be as easy as this. Yes, Ken?
If the velocity or the like
Any vector in the body frame equals the rotation matrix, this rotation matrix in particular, times the same vector in the inertial frame. It applies to velocity, it applies to anything.
it's kind of the position.
Any vector, I mean, in particular the velocity.
The velocity is a derivation of the position.
I don't care how did you get it. Now, to me, is a vector, right? Any vector has a components, and any vector can be written in any frame. As a vector, yeah, I understand that to get this vector, you had to differentiate with respect to the inertial frame. Any derivative has to be with respect to the inertial frame, period. That's fine. But now it's a vector. As a vector can be represented in any frame, can be represented in body, can be represented in inertia. So this can be velocity, position, acceleration, or any generic vector. Okay?
So just one thing, this phi beta sign, they are with respect to the which axis in this rotation matrix?
This is a very good question.
Because it's
Psi has a physical meaning. Why? Because it's the very first rotation about an inertial frame, an inertial axis, Z. Phi also has a physical meaning because it's the rotation about the body axis, right? Phi is about the S1, but it's the same as V1. So phi indeed is the roll angle.
what is the
Theta is a fictitious angle. Euler angles do not have physical meanings. This is very important. Okay? Very important. It's just a way to represent the attitude of rigid body. And even if this guy has a physical meaning, it's no longer seen in the motion. It's the very first rotation. You cannot see it in the motion anymore. You indeed can see this because it's the most recent one. It's about the body axis. That's fine. It's indeed the roll angle. But these two are fictitious. There are no physical meaning for them. In particular, this theta was indeed about an intermediate frame. It's purely fictitious frame. Right? Any question? Are we done with our objective, or there is a missing step? Not missing, but some step to complete. Are we done? The objective was to represent the attitude of a rigid body, and we know that the attitude of a rigid body is represented by a rotation matrix. Yes, indeed, we managed to write the rotation matrix in terms of our new parameters, Euler angles. But this is useless if you didn't tell me how these angles evolve with time, right? So this is the main thing. We want to know, given omega, how these angles will evolve with time. Let's do it. This is very important. We did 3 rotations. So what is the total angular velocity vector in terms of these 3 rotations? Let's do it one at a time and add them victorially. What's the first rotation? Angular velocity? The magnitude at least. What's the first rotation angle? Psi. So what is its average change? It's psi dot about what axis?
Z.
What?
N3.
N3. N3 or E3, right? And then, what's the second one? Theta dot, about what axis? E2 or S2, very good. And what's the third one? Phi dot about?
V1.
Yes, so it's S1 or B1. That's very good. So indeed, this is the angular velocity vector related to your psi dot theta dot phi dot. But this is in the body frame, this is in the S frame, this is in the E frame. We need to have them all represented in the same frame to add them together. Okay? So let's do that. So, omega in the body frame now, which is the given components omega 1, omega 2, omega 3. Let's just keep it for a second. Omega equal psi dot in the N3 or E3 is 0, 0 psi dot in the E frame, correct? Plus 0 theta dot 0 in the S frame. Plus phi dot 0, 0 in the B frame. Okay? Any question about that? This guy is already in the body frame. I need to just move these guys to the body frame. Okay? This is in the S frame. How many rotations you need from the S frame to the body frame?
1.
Yeah, very good. This is the old, and I want to get the new, just multiply by the rotation matrix. So